Hello guys, hope you're doing well. So in my previous videos, we've discussed about how our universe might have come into existence and then how our amazing Milky Way galaxy was discovered. In this video, we will understand how did our solar system manifested, the origin of it, the formation of our home, our planets. Our solar system consists of one smallish star, the Sun, 8 planets, a few billion asteroids, and a few more billion comets. Add to that masses of dust and gas, and there you have it. So let's take a tour around it. Close to the Sun, we have 4 small rocky planets: Mercury, Venus, Earth, and Mars. These are very much alike, each having a core made of mixture of iron and nickel and surrounded by a rocky crust. Venus, Earth, and Mars have significant atmospheres, while Mercury has almost none. They all are called terrestrial planets. Then beyond Mars, there is a space for another planet, but it's not there. What we have instead are the bits of that should have accreted, that means clumped together to make a planet. What we actually find are millions of bits of rocks and metals known as the asteroids. So asteroids are a bit of a planet that never happened. And it didn't because of the largest of the planets, Jupiter. Every time the asteroids try to accrete, they are ripped apart by Jupiter's enormous gravitational field. Jupiter itself is the largest of the planets, but it's not solid. Interesting, right? Jupiter is a gas giant, an enormous ball of hydrogen, the same stuff that Sun's made of. It's not the gas all the way through, only the outer layers are. But deeper in the planet, the pressure squeezes the gas into a liquid and then into a solid. Right in the middle, there's probably a small rocky core. Saturn is very similar to Jupiter, but is best known for its rings. Actually, all of the gas giants' planets have rings of some sort, but the Saturns are by far the brightest. Beyond the 2 real giants, there are 2 smaller gas planets, Uranus and Neptune. These are similar to Jupiter and Saturn, but smaller and made of different gases and are much colder. So all these gaseous planets are called as Jovian planets. Beyond Neptune, things get a bit confused. That far from the Sun, the disk of material that accreted to form the planets are really too thin to make more. Once the small particles had clumped together and were just a few miles or tens of miles across, so they were too far apart. So beyond Neptune, we find billions of lumps of ice and dirt. Some have more rock and dirt than ice, and others are predominantly ice. But they are all called comets. These comets can be found in a belt around the Sun beyond Neptune, known as the Kuiper Belt, and is a massive bubble that surrounds the whole solar system. This enormous reservoir of comets is known as the Oort cloud. So that was a brief tour of our solar system. Now let's talk about how did it form. So there have been different theories that explain many of the phenomena exhibited by the solar system. The leading theory is something known as the Protoplanet hypothesis. So once upon a time, about 4.6 billion years ago, as the theory goes, the location of today's solar system was nothing more than a loose collection of gas and dust, what we call today a nebula. By the way, Orion Nebula is one of the most famous examples you can see in the night sky. So the theory suggests that certain cosmic force caused the cloudy nebula to condense and surround itself with an immense flat halo of hydrogen and helium. Gravitational attraction within the material of the halo caused the huge saucer to pull apart into the separate units of whirling gas. This whirling gas formed a rotating disk divided into inner and outer regions of the solar system. In the inner region, the unborn Sun at the center of the cloud may have worn 9 or so necklaces, each made from perhaps 5 gaseous whirlpools. These were the unborn planets. As they were close to proto-sun, the lighter compounds vaporized while the silicates stayed as solids, forming small planetesimals. These small planetesimals accrete to form planets. Since force of gravity is proportional to mass, the largest planetesimals were accreted first. Smaller fragments were captured and held by the gravity of larger fragments, and the gaseous whirlpools formed bigger and bigger solid protoplanets and their protomoons. Meanwhile, in the outer solar system, the regions were colder, with more volatile ices and gases. Due to lower condensation temperature, a rapid accretion of icy planetesimals happened. That increased their already large masses. These are our Jovian planets, with Proto-Jupiter and Saturn to be more massive as compared to Proto-Uranus and Neptune. As the planetesimals shrink in the average size, collisions with the protoplanets lead to fragmentation. So quickly, the solar system divided into large protoplanets and smaller planetesimals, which eventually became the numerous meteors we see today. Any leftover large bodies were captured as moons or ejected by the gravity assist into the Earth cloud. So remember the gas halos that I talked about in the start? Now, the start of thermonuclear fusion in the sun's core created enough luminosity so that the remaining hydrogen and helium gas in those halos was removed by radiation pressure. As the young protoplanets bathed in heat and light of our sun, they became the solid, settled planets of the present orderly solar system.